evaluate the following limit. We have the limit as t approaches infinity of the natural exponential raised to the minus t times vector I minus 3t by t plus 5 unit vector j plus 2 inverse tangent of t times vector k. So to make this one a little bit easier, let's then evaluate component by component. So we evaluate each component separately. So we'll start here with our x component. So we have the limit as t is approaching infinity of the natural exponential raised to the minus t times unit vector I. So let's see what happens when we immediately evaluate. So I have the natural exponential raised to minus infinity times unit vector I. So simplifying this, that's 1 by the natural exponential raised to the infinity times unit vector I. And we know that an exponential raised to the infinity goes towards infinity or grows exponentially large. So this is 1 by infinity times unit vector I. And of course, 1 over infinity is going towards 0. So this limit we can write as 0 times unit vector I. So moving to our next part, we have the limit of the y component. So this is the limit as t approaches infinity of minus 3t divided by t plus 5. And this is multiplied by unit vector j. And so if we attempt to evaluate here, immediately we end up with minus 3 times infinity divided by infinity plus 5 times unit vector j, which leaves us with nonsense. We have negative infinity over infinity, which is an indeterminate form. So this does not exist, but it doesn't mean give up. It means that we need to simplify. So now that we've shown it as an indeterminate form, we can go ahead and apply L'Hopital's rule. So we now have the limit as t approaches infinity of taking the derivative of the numerator, we're left with a minus 3. Taking the derivative of our denominator, we're left with 1. This is multiplied by unit vector j. And since it's just a constant, we're left with negative 3 times unit vector j. So there is our limit of the y component. And last but not least, we want to go ahead and evaluate the z component. So we have the limit as t is approaching infinity of 2 times inverse tangent of t times unit vector k. And so at this point, it might be helpful to think back. We know that when we have y is equal to, say, tangent of x, and we wanted to find the inverse of tangent, we know that we have to restrict the domain of this function for it to be 1 to 1. And so we know that x here would need to be greater than, or well, not equal to, but greater than minus pi by 2 and less than pi by 2. So we think about this graphically. Here's our y-axis and our x-axis. And we'll say there's pi by 2. And here is minus pi by 2. Right? We know that the tangent function has asymptotes at these x values, at multiples of pi by 2. And the graph of tangent itself looks almost like a cubic function. And the reason we want to remind ourselves of this is when we think about the inverse of tangent, we're switching the coordinates. So inverse tangent of y is equal to x. So we can see, looking at this graph here, as our x values are getting closer to pi by 2, the y values are growing towards infinity. we can say that as x approaches pi by 2, y is approaching infinity. So when we think about this in reverse, we can see with this limit, if we have 2 multiplied by inverse tangent of infinity, this inverse tangent of infinity multiplied by unit vector k is approaching pi over 2, which leaves us with 2 times pi by 2 multiplied by our unit vector k, and these 2's cancel, leaving us with pi times unit vector k. So we have the limit here of our x component, the limit of the y component, and the limit of the z component. And so our final answer, and say therefore the limit as t is approaching infinity of 3 times the natural exponential raised to the minus t times the unit vector I minus 3t divided by t plus 5 times the unit vector j plus 2 inverse tangent of t times unit vector k is equal to 0 times unit vector I minus 3 times unit vector j plus pi times unit vector k. And we don't typically include this 0 here unless it's component form. Usually we would just write our beautiful final answer as negative 3 unit vector j plus pi unit vector k. So this is a beautiful final answer in our standard unit form. Or if you wanted to write it in its component form, we would say that the limit is equal to 0, negative 3, pi. So either one of these answers is great.